All right, I'm going to start with hot take. When I'm trying to do some little project, some experiment, whatever, and I need to use a dependency, I'm going to use fetch content in CMake, and I kind of expect my dependencies to bring everything they need at configure time by themselves. Like if a dependency wants me to use an external package manager to install another dependency, I'm not going to use it. I'm not going that way. I want my dependencies to behave nice. So if you are a library author, please do play nice and use fetch content to fetch your dependencies if you have any. Fetch content is really easy to use. You just need to give it a name of a download folder and you can point it to whatever, but most of the time you are going to point it to a Git repository, give it some tag or branch, it will download it, it will configure it, and boom, I have a linkable target. This is nice, easy, and for small to medium projects, it can even nicely scale. And if you don't have conflicting dependencies somewhere in the tree, it works just fine. But of course, sometimes you are going to have the conflicting dependencies somewhere in the dependency tree. So what happens here? Let's say we depend on dgmlib and fsmlib, and both of them depend on enlogment.json. Two things can go wrong. The first way is that they depend on vastly different versions of enlogment.json, but use a same name for fetch content download folder, which is recommended by the documentation. In that case, only the first fetch content declare will be satisfied. The other one will be skipped because the dependency is already fetched. There is no concept of version. So one of the libraries will link against bad version of enlogment.json, which can result in compile time errors, link time errors, or even worse, perhaps runtime errors. And I, as a user, kind of expected different behavior. I would like it to fail at configure time, which is not what happens. The other case is they both depend on the same version of enlogment.json, but use a different download folder each, which means the enlogment will be downloaded twice, configured twice, and when you get to the point where the same named target will be added the second time, the CMake will fail at configure time. And once again, this is counterintuitive to what I, as a user, expect. I would expect to simply work because both of them are using the same dependency. So, if you are making a library, you should always use find package to see whether you can satisfy your version requirements with something that is already available to CMake at that point of time, and if not, run fetch content declare. Also, optionally, you can try to encode the version you are downloading into the name of the download folder. This is in contrary to the official documentation, but it actually solves the problem where multiple dependencies download different version of the same library, so you get the configure time error. Also, both of these can go wrong in many ways, so it's best to also provide switches for CMake to disable both of these behaviors. Like if something goes very ugly, I can disable your dependency management in your library and figure it somehow for you. It is also good to know that find package isn't really meant to work with fetch content, although some attempts are there to make it work. And the main reason is that find package is meant to find install packages, installed through make install or something like apt-get. And the biggest pain point here is that while CMake has a concept of version of a project, it doesn't have a concept of version compatibility for the project. It does have a concept of version compatibility for a package, which is covered by a library name config-version.cmake, which is a completely optional file that you might or might not create. But for the sake of brevity, find package works really easily. It has list of directories it goes through, and it looks for your library name config.cmake. If it finds it, it also optionally looks for config-version.cmake. It executes it. It evaluates whether it satisfies the version requirement you have for find package. And if it does, it includes the library config CMake, and it contains a bunch of stuff that is supposed to set up your targets. But anecdotally enough, that file can be empty, which is really good if you're trying to make find package work. And you can also affect lookup of find package, preferably by appending a path to CMake prefix path variable. And the package config version.cmake is also really easy to generate. There is a macro for that. You just give it the output name, you give it a version which should be probably the same as your project version. And you also tell it the compatibility, which declares your commitment as a library author to backwards compatibility. You can tell it, hey, I'm going to break it with every single version. I'm going to be backwards compatibility up to version 001, or I simply mandate you to have the same major and minor numbers, and whatever patch has, it is backwards compatible. So even if you don't plan on making your library installable or packable, it is still a good idea to generate this file and at least an empty config file into the root of your binary folder. Because then when I'm resolving some package conflicts, I can simply point find package to look into your binary folder as well, and it will magically succeed and satisfy my version requirements. And when you look at libraries like nlogman.json or many more, they are already doing this. They are already handcrafting these files, and they're producing them during configuration. And that's pretty much it. I want it to be short. So 3 things I want you to take away from this talk. Always find and fetch your dependencies. Give me an expert mode where I can disable by switch both of these behaviors if something goes really, really wrong. And ideally create those 2 config files at configure time in your binary folder. Like I can create them instead of you when I'm solving conflicts, but you just save me a lot of time, or perhaps somebody else who is trying to use your library. And a shameless plug at the end, I created a game and published it at the end of August. I call it a perfect toilet break platformer because it has really short levels and you can play it on the toilet. It's completely free without any ads. You can play it on Windows and Android, so I will be really glad if you give it a try. Sorry. And the slides for this talk won't be anywhere because I want to write a full-length article about this topic. It was really interesting to research it. So just keep an eye on my Medium profile. I hope to publish it by next week or the week after. That's everything. Thank you. And perhaps if you have questions, you can ask me. Yes, it is a valid question to ask why I'm not using dependency managers like VC Package or Conan. Simple answer is there are many, many cases where I just don't want to use package managers, namely the package isn't there, it is a bad version, or I'm forking it and just doing some experiments and I want to plug it into something bigger. CPM would be like nice. CPM is just wrapper around fetch content.
Will you publish source code of the game or source?
I could make the repo public if you want to.
I've been looking for it already. I just saw an exe file.
Okay, remind me after the talk. I will set up to-do and publish it and send it to you.
Which graphics API or library did you use? Was it
SFML. It's written completely in C++. Of course, I couldn't present it here without that prerequisite. All right, if that's all, enjoy the evening. Or, okay, one last question.
How this fetch content works together in the environment where all the dependencies are managed by system-wide, for example, in Linux, where you have system libraries?
Well, find package will find packages installed through apt-get or similar. So that's the intended use case, to find those exact packages. And if you find them, you skip the fetch content if you did the find package guard. So it integrates really well. Okay, enjoy the evening.